Hi, my name is Fadwa. In this presentation, we will talk about a technology that I believe every IT department has to deploy. We all face problems with the current state of logging. One major issue is that there is no consistent format and it varies from one system to another by design and output logs. The other big problem is that logs can produce an overwhelming amount of information. The goal of this project is to solve these two problems, if not more, that every engineer or DevOps can encounter on a daily basis. The solution is by using ELK stack. Logstash solves both of these problems on its own way. First, it does a great job of abstracting out a lot of the difficulty with log collection and management. So, for example, you need to collect not only syslogs, which is the purpose of my project, but maybe you need to include MySQL logs, Apache logs, etc. on a system. Logstash doesn't discriminate. You just tell what Logstash to expect and it will go ahead and process those logs for you. With Elasticsearch and Kibana, you can quickly gather useful information by searching through logs and identifying patterns and anomalies in your data. ELK consists of three applications that handle input, storage, and analysis of log data. The components are Elasticsearch, a powerful open-source search and analytics engine that makes data easy to explore. It's a search server based on Apache Lucene. Logstash, a log management tool used for centralized logging, log enrichment, and parsing. Kibana, a browser-based HTML5 dashboard used to visualize Elasticsearch data. The open-source ELK stack provides the ability to perform operational and data analytics, including deep search functionality on almost any type of structured or unstructured data source. Each component can be used without the other, but the combination of the three is common and hence the name ELK. The principle of my main goal is to centralize logging and extract system logs for debugging or analysis purposes from a single source with a user-friendly interface using a powerful search and analytics platform. In order to understand the principle, it's a good idea to briefly list out the advantages of utilizing ELK stack. It enables you to search all your logs in a single location. It allows you to identify any issues spanning multiple servers by correlating all the logs within a specified time frame. The three components necessary to come up with the ELK stack are all open source tools, which means it's free and all of us like free stuff. The stack installation process is pretty straightforward if the environment is carefully selected in terms of RAM, disk space, and the config files are configured correctly. The ELK stack gives you the power of real-time data insights, with the ability to perform super fast data extractions and real-time analytics. Elasticsearch is the engine that gives you both the power and speed. With Elasticsearch, you can start small and expand it along with your business growth when you are ready. It's built to scale horizontally out of the box. Hence, you can set up multiple indices and query each of them independently or in combination. Elasticsearch uses Lucene to provide the most powerful full-text search capabilities. The search features come with multi-language support, an extensive query language, geolocation support, and context-sensitive suggestions, and auto-completion. You can store complex real-world entities in Elasticsearch as structured JSON documents. All fields have a default index, and you can use all of the indices in a single query to get precise results in the blink of an eye. Many more advantages you will discover as you work with an ELK stack depending on the purposes of use. The minimal Logstash installation has one Logstash instance and one Elasticsearch instance. These instances are directly connected. As the use case for Logstash evolves, the preferred architecture at a given scale will change. Depending on the situation, the ELK stack can be scaled by adding additional nodes, as in the diagram below, as Logstash 1, Logstash 2 for Logstash processing and Kibana web interfaces, or maybe scale the Elasticsearch master data node by building out additional nodes and they will join the cluster. This slide shows the flow of data in my ELK stack. Logstash collects data in the form of syslogs locally in the EC2 instance. When Logstash receives these lines, it applies filter plugins to them to extract the relevant data fields, such as timestamp, source, etc. Filters can also be used to add, remove, or alter additional data fields or tags. After the filters have been applied, Logstash outputs the data to Elasticsearch. Once fed into Elasticsearch, the data is stored for fast retrieval. Elasticsearch is a distributed document repository to store JSON documents. It provides rich and powerful functionality to query and search data within the documents. Queries are expressed in a custom query language and submitted via an HTTP API. Kibana finally uses HTTP requests to the API to provide flexible web-based access to Elasticsearch. Kibana is a rich web-based application being integrated with Elasticsearch. It quickly generates quick searches that can be dynamically narrowed down based on fields found in the log data, and it's possible to store individual search configurations. Kibana can also quickly generate real-time visualizations important for making any business decisions. In no time, syslogs can get to thousands of files, and with data processing, these logs can become overwhelming in terms of the volume of data. In this project, I used a single host installation where the Logstash serves as the syslog server, and so syslogs are collected directly with Logstash. However, native syslog files can take up less storage than logs processed with Logstash and Elasticsearch. And because we can be limited by the amount of storage available, I came up with a solution is to archive all raw syslogs into Amazon S3 bucket and delete them along with the processed data from the Logstash syslog server after a specific period of time of being indexed and searchable with ELK, maybe by creating a cron job or some other process. In the event that there was an audit or a security incident, we need to get a hold of the old data. So we can ingest syslog files from Amazon S3 into Elasticsearch using Python API. My enhanced architecture would look like this with the addition of Amazon S3. Here's a sample of my first dashboard in Kibana with different types of visualizations. This is a closer look at one of the graphs, being an area chart. This shows the activity rate represented by count on the y-axis and timestamp of each event on the x-axis. Thank you for watching this video.